All right. Good morning, everyone. So today we are going to go through some R&R Studio intro. From the survey, I could tell that maybe, I don't know, 70% of you are already familiar with R, especially if you are taking another one of my courses or taking that in the past. It's going to be something that you are going to be very familiar with. But it is important that we go through slowly, especially for those of you that do not have any knowledge in R or R Studio. This is important for us to understand the syntax, understand how things operate before we really start getting to some more complex coding. So today is going to be very slow. We're going to start very, very easy introducing R in R Studio, and that's the plan for today. So what I did last night and I want to do together with you now is I uploaded to our GitHub page. So if you don't have that bookmarked yet, you should probably do that. So if you go on github.com/Leo M. Bastos, that's my username, /2024_DSA for data science applied to ag. That is the repo of this class. And I just want to show here. So last night I uploaded, or I pushed in Git language, a code to the 04 class code folder. So it's this code right here that we're going to be developing today. I just want to go back here. So just to get you familiarized, for this class specifically, today we're going to simply download the repo, just like you did the first time when you were doing the package installation. So we're going to click on that blue code green button, click on download zip to download the entire repo. Maybe this is going to be the only time that we're going to, or the last time that we're going to be downloading this way, because maybe in a couple of lectures, we're going to get introduced to Git and GitHub. And at that point, we're not going to be doing the download like this anymore. We're actually going to be just doing a Git pull directly on your computer, which basically downloads for you already anything new that's in the GitHub. You can kind of think of GitHub as a cloud, your computer being the local machine. So on my local machine, I push the updates to GitHub. They appear on the cloud here on GitHub. And then on your computer, if you're already connected to this repository through Git and GitHub on your computer, then you just do a Git pull and bring that down to your machine as well. So again, today is probably going to be the last time you're going to be manually downloading this repository here. We're going to be doing a Git pull from the, after we go through Git and GitHub. Okay, so if you do that, click on that green button, click on download zip, and you download this zip to your computer. I just want to show you here on my side what I want you to do. So if you don't have yet a folder for this class, I would encourage you to create a folder somewhere in your computer for this class specifically. So mine here is this one is called data science. I mean, it's the name of the course itself. And then inside of it, I have this folder that is the 2024_DSA, which you can kind of think of this on your side as being the one you just downloaded from GitHub. Okay. So this folder, I want you to have a main folder for the course, and then inside of that main folder for the course, you at this point you just download this folder that you downloaded from GitHub. You're just going to move that in here. I think yours may say 2024_DSA_main. If that's completely fine, is because you're bringing that from GitHub. So if you bring that folder here and you go inside of it, I have a few extra folders that you are not seeing yet, but the ones that we share at this point in common is 01 packages and 04 class code. So you should be seeing the 04 class code. If you go inside of that, there's going to be this 0111 intro R partial.R. So this is a .R script. It's an R script. We're going to start using this one just for the introduction. We're probably not going to be using a lot of it as we move forward, but I do want you to be familiar with it. And the way that this course is going to work is I will share with you partial scripts, so partially filled scripts that we then develop together in class. And then only at the end of that script, which could be one class meeting, it could be maybe a couple, but only at the end of that, when we complete in class that script, is when I then upload to GitHub and to my website the full completed version of that script. Meaning that it's really important that you follow along in class. If you get lost in class, please let me know. Sometimes I tend to go a little bit fast because I get excited. If I'm going too fast, please let me know. If you got stuck on, especially now in the beginning, especially if you're new to R, you will get stuck, you will make errors. Everyone makes errors. I make errors. So, I'm glad to take a moment, especially now in the beginning when we're all getting acquainted to it, to stop and troubleshoot and make sure you're following along. And if it is something that is more complex, like, I don't know, if you, for some reason, have a completely different version of R and packages are not working, I'm not going to be able to help in class, but I can see you afterwards, and then you can use the recordings to catch up later on. But it's important that even if you miss a class, if you have to miss a class, that's completely fine, as we talked about in the first meeting. But it's also important that you catch up soon after that, because if you leave it behind, you will fall behind. Because this class, what we do today what we do next class is going to be a continuation of what we did today. So if you miss today and you just come to the next class without catching up, you're not going to be able to follow along. Okay, so I guess getting back to here, if you just want to copy this script here, and then I want to go back to where I was, go back again and see again the main folder of the course. So here I want to create a folder called 01 intro. And in this folder, I want to paste that script. Yes. Oh, thanks. I think it's telling me that's the max I can go. Let's see, we don't have any seats in the front. Do you want? Yeah, it's hard for all of you to see in the back. Yeah, so it's not letting me increase with Command Plus. I can. Command Plus.
And or you can open the Zoom link from that computer and you can see open the Zoom computer.
Yeah, that could. So let me see here, because I tried increasing the font size in my Mac in the past of like the whole system, and I didn't find an easy way to do that. So you're saying that you're doing Command Plus, and that's increasing with Windows. Yeah. Yeah, with Mac, I think it just increased the size of the folder. Okay, so and this is really so once we get into R, then I can increase the font easier. So this is, I mean, if you think you can make it through at least this initial setup, then we can. But so yeah, okay. So let me just then, I guess, narrate better what I was doing if you cannot fully see from the back. So on the main folder of the course, you have this 2024_DSA. In your case, probably has a main at the end. That's what you brought from GitHub. If you go inside of that, there's going to be a 04 class code folder. If you go inside of that, there's going to be a script. You just copy that script, go back a couple times, go back to the main level of the course folder, create a subfolder called 01 intro, and then paste this script in there. Was everyone able to do it, or was someone not able to do it that needs help? Okay, so I just want to come back one level here and just tell something before we actually get started with that script. So both now that you, I guess, manually downloaded, but also after you connect your local Git with GitHub and you start just directly downloading through that, the contents of the GitHub repo, I just want to tell you that this folder, the 2024 DSA main in your case, please do not save anything of yours in there because this folder is going to be continuously updated. And if you save something of your own in there, it may cause issues for you. So you may lose your work, and I don't want that to happen. So think of this folder more of like where you go to just fetch data or scripts that I share with you, but then you copy. I mean, if you want to move, you can move, but you can copy those data and scripts into the working folder that you're going to work on, which is what we're doing at 01 Intro today. And that's where your script's going to be saved, right? So I just want to make that very clear. Do not like, so one thing that has happened in the past that I want to avoid that this time is, let's say some students would go into the 2024 DSA main, go in class code, and then edit this script here. And it's going to work. It's not going to give you any errors, but I don't want you to do that because next time that I update the repo, maybe your work may be lost. So I don't want that to happen. I want you to actually, copy that script into your working folder that we're calling 01 Intro, and then working from there. Okay, so today, let's go ahead then and get started. So make sure you are in 01 Intro, you're seeing your script there. Let's just double click on that and get started. So if you just double click that script, it should prompt your RStudio to open like it did on mine. Mine may look different from yours. I changed the colors. It may be a different look to what you're seeing, but that's completely fine as long as that open in RStudio. If this did not open in RStudio, then let me know. All right, so just a few housekeeping items is on this script here, I'm giving you again the link to the class website. I would highly encourage you to bookmark this website because we're going to be referring to it a lot in this semester. And mentioning again that every time I share with you new partially filled scripts, new data frames, and also the final completed scripts, I'm going to be doing that through GitHub. And then every class is recorded. So this class is going to be available to you later today on my YouTube channel, and also a link for it's going to be included in the website. Okay, so before we do get started with talking more about R in RStudio, I just wanted us to set up our RStudio environment to avoid a couple things that can happen in the future. So the first one here is, if you ever use R, you may have noticed that the default behavior of R is to save your environment variables. If you don't know what I mean by that, you will learn that by the end of this class, of today's meeting. But this is your environment, and any objects that you create are displayed in your environment. And R by default saves that environment from one session to the next, which unfortunately it is the default behavior. I don't want that to be, because I've seen many times, especially as your analysis start getting more complex, which we will be doing complex analysis in this course, you don't want a ghost of your previous day analysis to come into play into your today's analysis, because that creates a lot of issues with reproducibility. So we're going to change that. And the next thing that we're going to change here in a second is, if you're not familiar with it, so this is an R script, so a .r file. We're not going to be using a lot of this after today's class, but so .r files, R markdown files, Quarto files, if you're not familiar with them, you're going to become, but they're all different types of scripting files in R. We're going to be using a lot of Quarto files, except for today. But all of these files, if you see this like table of content icon here, they have this option that you can toggle on and off, and that shows you basically a table of contents depending how you set up your script. So this other setting that we're going to change is just to, whenever we get to Quarto or R markdown files, that this table of contents includes some more information in it. So let's go ahead and make those changes together. So this, you would go to Tools, Global Options, under the General tab on the left, which we already are in, under Workspace. So here's Workspace. If this button is checked for you, please uncheck it. And then you can change this to Never. And please go ahead and click Apply so that that is applied to your session. Okay, so again, let me just go from the beginning. I clicked on Tools, Global Options, on the General tab, which is already selected. Under Workspace, you want to uncheck the Restore and change this to Never and click Apply. The next thing we want to change and be already set up for coding is still here. So if you didn't close this window, we're still here. We want to come now to the R Markdown on the left side here, on the left side menu. And then it has here Show in Document Outline. We want this to be sections and name chunks. I believe that's not a default. Maybe it has changed since last time I noticed, but because I changed already in the past, mine already shows this way. If yours doesn't, you want to change this to sections and named chunks. And click Apply and OK. All right. Does anyone need help doing these steps? All right. So as you're going to notice, if you do have issues, let me know. I will always try to remind myself of making this couple seconds moments to allow you to ask a question. If you do have a question, that's, I mean, you can ask anytime, but that's one occasion that you can use as well to ask a question. If I don't hear anything, I will keep going. All right. So from today's class, if you're not yet, I want to help you become familiarized with using R and RStudio, learn about R terminology and syntax. I think that's a really important step if you're new to R, because I think that a lot of things in R and really any programming language we can learn online, but maybe the first steps, the beginning of just understanding how the language works. Is that better? So I saw you squinting. I was like, okay, I should increase this font size. Please let me know if it's not. Yeah. So learning about that terminology and syntax, so you feel comfortable doing understanding what's going on. So R has different object types that are important to understand what they are, how they operate, when you use them, and how you know what type R thinks something is. So we're going to do that as well. We're going to then create a simple data set and explore it with numbers and graphics, and then learn about RStudio projects. I think we're going to be able to do this by the end of this class, but if not, we'll do in the next period. But we're going to do RStudio projects and set up things. I guess I don't want to talk much more about that before we get to it. Okay, so the first thing that I want to talk to you is, why R? So for me, when I was doing my master's, I was using mostly SAS. And I had a PhD student in the same lab that I was sharing an office with, and he was using R, and I thought it was so cool, it was so nice. And then I really got more interested in learning it. And then I realized it has a lot of benefits, especially over proprietary software like SAS. I don't really know if a lot of the newer generation of professors, even in stats, I think SAS as is probably going to fade away the more people start learning about R and Python for many different reasons. And for me, the big ones is that R is free. It's open source, it's a free software. For me, that was really important. I'm from Brazil, and at that point in my career, I wasn't sure where I would end up. And if I went back to Brazil and I only knew SAS, then I would have to either find funds to pay for that license, which is very expensive, or use a pirate version of some sort, which is not really great, I guess. And so finding something that was free, open source was really important to me, especially having that mindset. And I know a lot of you here are coming also from developing countries where if you go back to your country and you're only using proprietary software, you're going to face the same issues. So being free was a big plus for me. Also because it runs on multiple platforms. So things like SAS, ArcGIS, SigmaPlot, where the things that I was using before are all, they only work with Windows, and I was already working on Mac. So of course there are ways around it. You can install different software to run these software on a Mac, but it's not optimum. So the fact that R runs on a lot of platforms like Mac, Windows, and Linux were a plus for me as well. If you're already been working with R, you know that the online community is very, very great. If you have a question, if you just Google it, you're probably going to get an answer very close to what you were facing. So that online community and support is really strong. If you have not worked a lot with RStudio packages and RStudio products, the RStudio community around R is really, really big, inclusive. It's a very vibrant community that helps a lot as well. And we're going to be using a lot of packages developed by RStudio. I hope you're going to feel that as well as you learn about these things. So the community and the support are really strong, really big points for me as well, that really helped me to learn. I remember when I was doing my master's running SAS, if I had an issue, I would say how to do this in SAS. I would find this technical page on the SAS website telling me a lot of things that I didn't even know what they were talking about. And it was not very intuitive. Whereas with R, there's Stack Overflow, there's other sources of asking and answering questions related to it that makes it very, very helpful. And then lastly, reproducible research. I think we talked a little bit about this in the last class period. I'm sorry if I am repetitive sometimes. I'm teaching 2 courses, and the beginning of these courses are very similar, so I may have told you things more than once. So bear with me if I do that. But really, reproducible research, I think it's a big, big part of it. We're going to have a lecture on this next class period. I'm going to share with you some data and some more case studies. But really, and R is, any programming language really that you use helps you with reproducible research. So it's not specific to R, but R is one of them that as you're coding, if you think of it, the code is your documentation. You're already documenting what you're doing simply by coding, right? Because the functions are doing something. And if you want to go back and see somebody asks you, oh, how did you come up with this data set? Or how did you process this data set? You can go back to them and say, hey, this is the script. So I had to first filter this. I selected that. I grouped by this. I got the mean. It's all there, right? It is your code, is your documentation. And that does not happen on point-and-click software. Even though point-and-click software are more friendly, especially if you're learning something for the first time, they do not offer you the option of documenting what you're doing natively. If you're really good about it, you may start taking notes, like how I went in Excel and I selected this column, I did this and that. But I don't know who does that. So by using a programming language, that helps you to make your research more reproducible. And by that, what I mean is, if you share with me your code and your data, and we have the same software, I should be able to reproduce exactly the same results as you did. And at least that part of it should be reproducible, right? So that's what we're talking about in this case. And so, these days, a lot of journals are asking for share your code, share your data. And by learning these things and learning other reproducible research methods helps you to do that in a way that people can reproduce what you're doing. Okay, so that's basically about R. Now, if you're new to R and RStudio, you may be a little bit confused about that, why we're using RStudio. Can we not simply use R? So RStudio really integrates a lot of different components of an analysis in the same window. I don't know if you had a chance to just open R by itself. R by itself is this window here. That's it, right? So if you think of it, before RStudio or before other IDEs were available, people would have this screen, which is the console. So this is where you send code to be interpreted and get something out of it. And they would have a different window for the code. If you're creating a plot, it would yet be a third window. So it was kind of like all scattered on your window, on your computer screen, and it was not very organized. So RStudio combines all of that into one window. And we're going to be talking about some of those parts here in a second. Another thing that RStudio does that R doesn't natively is give you color syntax. As we start coding, you're going to see how things are going to have different colors. So depending if it is an object, if it is a function, if it is something that you're printing, it's all going to be colored differently, which helps you to understand better what you're doing. And also gives you syntax suggestions. So what I mean by that is, so let's say if I start typing here, you don't have to do this, I'm just showing you, but if I start typing the function mean, there's a function called mean. As I start typing, it already guesses what I'm trying to say. It tells me the function name, it tells me the package that's coming from. You can click on it. That works for both packages, but also argument names. So arguments would be options within a function that you can change. So if I come here and I hit tab, it gives me the options of the arguments that I can change right there. So this, again, is something that RStudio gives you that R doesn't natively. So that's why RStudio is, and RStudio is not the only one. You know, some people use other IDEs. There are some, there's one by Microsoft that is VS Code. So, yeah, VS Code is one. VS Studio. Yeah, VS Studio. I use it a little bit, but I found that some of the components of RStudio I was missing, so I just came back to it. But there are others, right? So RStudio is not the only one. You do not have to use RStudio if you don't want to, but it's definitely the one that I would encourage you to use for this course. So let's walk through some of the RStudio panels. That's going to be important for you to understand what happens in each one of these panels, so you get familiar with it. So normally it's divided into these four quadrants here, like that. So normally the one on top left is going to be your script. And something that just, you know, if you're new to R, I want to make this very clear that your script, regardless if that's a .R script, if it is Markdown, if it is Quarto, whatever it is, that's where you should be coding. That's where you really develop your code and then you save it. You need to save your code so you can reproduce it later. When we run a piece of code that's on your script, we send that to the console, which is on the bottom here. So that we send that over here, that gets interpreted, and then we see a result of that somewhere. But so the script here is not where the magic happens, but it's where you write your code and then you send that to run on the console. On the bottom left here, that's the console. So when I open R by itself, you can kind of think of that R window as being this. This is where R is actually interpreting your code and giving you something back. So normally I only code straight out of the console if it's something that I do not care about saving. So let's say, oh, I just want to be able to, I don't know, do a quick math. Sometimes I open R as a calculator. I just want to do, I don't know, a division here, right? So I do on the console. It's not, I see the result there. I can use this, I can copy and paste, but it's not saved anywhere, right? So if you're coding something that you care about, that you want to save, that always do that on your script, and then from the script you send that to the console to be interpreted. Okay, the next panel here is the environment. So this is where we're going to see as we start developing the script and creating objects, they're going to start appearing here. This is also where some of the Git options we're gonna be using through here, but I don't want to get into that right now. But so this mostly is where your objects that you develop in that script are going to appear. And then lastly, we have on the bottom right here, we have another quadrant that is actually very important and has a few different tabs here. So if you're using an R script and you create a plot, that plot's gonna appear over here under this plots tab. This files tab here basically shows you where this file lives. And this is gonna become very important when we start setting up our RStudio projects, which is probably either by the end of the class today, towards the end of the class today, or next class period, we're gonna do that. So we're gonna talk more about it next when we get to that point. Also has your packages. I really don't use this packages tab much, but if you were to load your packages by hand, you could come here and just click on them. I don't really do that. If you want to install packages by hand, you can click on this install and go through that. But I think we can do that by code. It's more reproducible. And if you ask for help, so let's say if you want to know the documentation of a given function, and you want to know, how to use that function, you can use a function called help, and then you can give a function name. So let's say mean. that pulls up the help for that function under this tab here. And we're going to go through a little bit more of this later today. All right, so that's basically RStudio in a nutshell. And just wanted to get you familiarized with that. Okay, so let's begin with a little bit of coding. Again, today is going to be very simple. So this may be, if you're already familiar with R, this is going to be you're going to probably know a lot about the things that we're talking about. But if you're new to R, this is going to be a good starting point for us to understand. So one very key concept in R is the concept of an object. So an object is basically you do something and you want to assign the result of that something to a name that then you can call on later. So it kind of like saving your result to an object that you can call later, but without saving to file. It's just like temporarily saved on the memory of that R session. That's kind of what an object is. And so before we create an object, I just wanna walk you through here. So we can use R as a calculator. We use that a lot actually in more complex settings. But let's say if I want to do like a division. So let's say I want to do 45 divided by 13. So the math notation is similar to Excel, so you should be familiar with that. So okay, so this is my script, right? So for me to send this over to the console, there are a couple of different ways, but I want to show you a shortcut that I use a lot, which is if you have your cursor blinking anywhere in this line, it does not have to be the beginning, it does not have to be at the end, you do not have to select it, but just anywhere in this row here. And on a Mac, if you push Command Return, on a PC, I believe is Control Enter, that sends this piece of code to the console interprets it, and then spits out the result. Okay. I do want you to get familiar with that shortcut, the Command Return or the Control Enter, because we're gonna be using that pretty much every single time we send code to the console. Okay, so I did get the result right there, but it's just in my console, right? So what if I actually want to use this number for something? In this case here, there's no, we're gonna be reutilizing this number down the script. But if it is a research, you may think of like, I don't know, you're extracting a mean and then you want to plot that mean. So that's kind of the mindset there, is you want to reuse this again for a different function. So let's save this as an object that I want to call A. So to do that in R, we use the assignment symbol, which is less than dash. So every time that I say, because I'm always kind of narrating the code that I'm writing. So if I say, object name, assignment symbol, or it can also be called gets. So A gets something, that's what I refer to. So let's just copy and paste this easy math, this formula there. And then again, if you have your cursor anywhere in that row, just run it. You're going to notice a couple of things. So it sent this to the console, but it didn't give us anything back, right? But it may also have noticed that now you have this A object on your environment. And because it is a single value, it's already showing us what that value is. So now if we want to print on the console what this object actually is, you can just type again A and just run it. So we're basically just running the name of that object on the console, and R understands that when you do that, you're actually just printing it. This may not be the case in other languages that you actually have to say print A, but in R, it understands that you're trying to print it, so it's very straightforward like that. Okay, so we have this object called A. It has the result of this calculation here. Now let's start creating a few other objects. So let's create an object B. So let's say B gets, and I want to give it a few numbers. So let's say I want to save 3 numbers into B. That was going to be 10, 15, and 5. If you run that, it's giving you an error. And even though the error may not be very intuitive in this case, the error message, but the thing is, every time that you're trying to give more than one item, we have to concatenate those items together into one bundle and then give that bundle instead of each one of the numbers separated by commas. To do that, there's a function in R called C that stands for concatenate. So if you type there C, open parentheses, and then close parentheses at the end, and you run this, now we do not get any errors. We see that B appeared on our environment. And if I just want to print B so I can see its contents, I can just type B and then send that to the console, and then it returns back those three numbers that we created as part of B. All right, so next thing is, so up until this point, we gave one number, we gave three numbers. So what if you need to use a character? What if you need to give a word or even a sentence and save that into an object? Let's do that here on this object C. So we say C, get symbol. And because it is a word, it has to be within quotation marks. So let's say precision ag and make sure it is within quotation marks. So now we can just go ahead and run that. You're going to notice again that pops up on your environment, and we can just go ahead and print it below so we can also see the contents of that. So really objects, so right here we're assigning, very simple contents to an object. A lot of times your objects are going to be data frames, and those can be very complex and have a lot of information, a lot more than what we're showing here. But we want to start slow so we get the concept. Okay, so let's now create a data frame and assign that to this object that I'm calling D. So go down there, give it the assignment symbol. There is a function in R called data.frame. And I want to have one of the columns here, I want to call it number. So I say number equals, and then I could give manual numbers here if I wanted, but I want to assign this column to the object B. So if you remember, object B has three numbers. So I'm creating a data frame with a column that I'm calling number and assigning the values of B to that column. And I want to have another column here. So for us to do that, I just add a comma. I want to hit return or enter just to break the code and make it a little bit easier to read. And I want to call this next column ID. And the contents of ID, I want that to be equal to our object C. So whatever is in C, which is one word, precision, or a sentence, I guess, precision ag, is going to be assigned to this column ID. So if you go ahead and run this, you're going to notice again that it appears on our environment. And if you print it, you're going to see the contents of that below on the console. So notice what happened here. If you recall, the object B had three different numbers. The object C had one single word or one single component, right? Precision ag has one piece of it. So what happens is R basically started with that number column, gave it the three numbers. So this data frame has three rows because of that. And then it saw that the object C only had one value that was precision ag, and basically recycled that value and filled in the gaps to make sure that the final data set had, the same number of rows for both columns. So that's what's going on here. Okay, so this, one of the ways that you can, if you need to create a data frame in R, you can use this function data frame. I use this sometimes, but most of the times I'm reading data from file, right? So I want to make you familiar with the function, but at the same time, it's not going to be the main source for you to be reading. I mean, using data in R is not you coming and typing your data yourself. It's going to be bringing from file. All right, so the next object type. So we talked about data frame. This is a data frame object type. The next object type I want to talk about is a matrix. We in this course are not going to be using matrices a lot. I don't think we are going to use it at any point. It doesn't mean it's not important, right? So matrices are being used a lot behind the scenes. So when you do any type of modeling, it is a matrix-based calculation that happens in the behind the scenes. Even though we don't see them, they are used by R a lot. You may not use them for what you do directly, but I just want to make you aware of this type of object. So let's create a quick matrix here. So we come to this object E, we give it the assignment symbol, and we use this function called matrix. So what I want to have here is I want this matrix to have the values of B 2 times. Because I'm giving it B 2 times, I need to use a function concatenate, so that's the C function. So I give B, and then I give B again. And then when I'm outside of that parentheses of the C function, I want to add a comma. And there's an argument called ncol. That sets the number of columns of this matrix. I just want to say ncol equals to 2. If you run this and you print it, this is what we see. Notice how a data frame is different from a matrix. Even if if you set up a data frame to be similar to a matrix in the way that you set up the number of rows and columns and so on, there's still 2 different object types. One thing you're going to notice here is that a matrix does not have column headings, right? It only has positions. So these are the positions of the columns. These are the positions of the rows, but it does not have column names or row names for that matter. And then you see that it basically took the object B and then filled in this direction, and then again this direction, and that's a matrix. All right. Let's go to the next object type here. That's going to be a list. So we're going to be using lists. Well, let me just take one step back here. So we're going to be using a lot of data frames. So you're really going to be very familiar with how to handle data frames in this course. We're not going to be using any matrices, but I did want to expose you to that concept. And lists, we're going to be using a little bit, and they're going to be very important when it comes to doing iteration in R. So if you think of it, if you're familiar with some programming concepts, if you're doing any type of loop, there is one way in R that we use lists for that is very efficient, and you're going to be seeing a lot of that at some point. So lists is an important concept also for you to understand. So let's create this list here. Let's give it the get symbol. There's a function called list that we use to create lists. So on this list here, I want to first create a component that I want to call number. Let's open and close quotation marks and call number. And I want to say number equals to A. If you recall, A is just the result of that calculation. That is just this number here, 3.46. After A, please add a comma, and let's add another component to this list that I want to call numbers. Open and close quotation marks and type in numbers. And I want to say numbers equals to B. If you remember, B has 3 numbers in it. Add a comma. Let's hit return or enter here just to break the code and make it a little bit easier to read. The next component of this list, I want to name it as word. So open and close quotation marks, and let's call it word. And I say word equals to C. If you recall, C is that 2 words precision ag. And lastly, add a comma there. I want to create a component called data. So open and close quotation marks and write data equals to D. If you recall, D is that simple data frame that we created. I just want to leave it up a little bit here on the screen in case you're still catching up. A few very useful tips. Remember to check if you have your commas in the right places. Remember to check if your components of this list are all with quotation marks. Because those, and make sure also that you have your closing parentheses of that list function. Those are some of the most common issues that we see a lot of times is you have a missing comma, you have one field or one extra parentheses where it's missing something. So if you're able to write it without any issues, you can run it, and it it should run smoothly. It should appear on your environment, that F object. And now let's just print this object F. Okay, so what we're seeing here is that this list has these components that is using the dollar sign to indicate each different component. So dollar sign number, dollar sign numbers, word, and data. And it's getting each one of the values that we gave it, right? So one of the key differences between a data frame and a list is that a list can contain data that is not conforming across the different pieces of it. So if you see here, we go from having one number to three numbers to a word to a whole data frame, and all of that is saved into the same object that's the list. So with data frames themselves, we don't have that flexibility. And this is what a list allows us to do differently in R. I want to expose you here to a function that is very simple and yet can be very important in some parts of your analysis, which is a function called class. So the function class, we use it when we, yes.
I'm sorry, Diego. I just wanted to ask a question. For example, if you have inconsistent spaces in the codes, does that affect the code as well?
You mean like if you have extra white spaces like that?
For example, after that, if you form a sign, if I do not have a space before that A.
Before, like if you had this, no, that is not going to create an issue. A lot of times this just comes down, at least in R. So of course, like if you have an extra space here, that makes a difference, right? But if you just have extra spaces in places where you're not breaking anything, like you're not breaking a word or not breaking, so extra spaces do not make a difference in R if they are placed in those in between things. Yeah. So it is common practice, and especially like if we think of like best coding practices, it is common to have this type of approach where you give a white space between things. You don't have to, but if you see the best coding practices of like Google and Facebook and things like that, there's a whole bunch of little things that we can do to make our code more, I guess, interpretable by other people. I mean, including us, I guess, the owners of that code. So this is just one of them, but you don't have to do it. That's a good question. Okay, so what I was, and thanks for the question, I appreciate it. Talking about the class of an object. So what happens is R interprets things or assigns a class to a given object, sometimes by itself, and most of the time that is the correct one. Sometimes it's not. And we're going to see when that's not, when we start doing experimental design analysis. But I want to show you here what's the way that you can, what can you do to learn how R is interpreting a given object's class? Because that object class is going to impact how that object is used, what functions can be used with it, how it responds to functions. So it's important for us to know that. So there's this function called class. So if we just come here and do the class of the object F, which is a list, it comes down as a list, right, as we would expect. But because F is a list and it has different components, these different components, each one of them have their own class. So we can come here and check the class of F, but then let's use the dollar sign to kind of go inside of F and choose one of those columns. Let's use this column number. So let's inspect what's the class of that column number, or sorry, not column, the component of called number in this list. So it is numeric, right? So I just want you to be aware of this, and especially in data frames. So if we come back to I'm just going to print it here. So on this data frame here, this column, so even though the object D is a data frame, and we can learn that, so if we just ask for class of D, it comes as a data frame. But the columns of that object, each one of them have a different class. So if we do D $ number and run that, that is numeric, which should be numeric, right? Because it is a number. So I just wanted to make you aware of each object and even parts of that object. If it's a data frame or a list, have different classes, and this is how you would know what that class is. Okay. So let's talk about functions. We've been using a lot of functions already, but I just want to take a moment to talk about what is a function, what makes something a function in R. So normally a function is going to be a word followed by an opening parentheses. You get some stuff in between, and then it has a closing parentheses at some point. So that would be what a function is. And I want to expose you here to a function called mean. So if you just start typing that, so this is the function mean, which you may imagine is going to give you the mean of a series of numbers. So let's give this function here the object b, which if you recall, object b is 3 numbers. So let's just get the mean of those 3 numbers. Okay, 10. That makes sense, right? Also, let's just type this function mean again. And if you hit tab here, it's going to show you, in this case, it shows you like one of the argument options of b. And because my text is larger, we cannot see the whole thing here, but it's basically going to say that what this argument does. So this is the argument that you specify what you want to get the mean of, right? So in our case, we can say mean x equal to b. It's going to be the same result as if we did not specify that argument name. However, arguments are really, really important. And in this case, it's very trivial, but it's going to get to a point where you're going to be changing arguments inside functions. And I want to know how to learn about what arguments there are, what values can they take, how can you change them. So the easiest way to learn that is to use the function called help. So go ahead and type that, open and close quotation marks, and then type function mean. So we're trying to get the help for function mean here. If you run that, you should have populated some text here on your bottom right panel under the help tab. So I just want to walk you through a little bit here through some of the documentation of this function. And I want to tell you how I use the help function. So if I know what function I need to use, I just need a refresher on, oh, I want to change this behavior of the function. I want a refresher on what is that argument and how can I change it. I use the function mean. I use the function help to learn about that. However, if you have no idea what function you need, like, oh, I want to do a plot for the first time in R, I have no idea how to do it. I do not use a help function here. I go to Google or, ChatGPT if you wish, whatever it is, right? So the help function, I use it a lot on my day-to-day analysis when I'm trying to remind myself of a function that I know how to use. I used in the past. I just need a refresher on how to use it. I use help. Other than that, I use Google to learn about something. Okay, so if I'm looking for the help of a function, this is a very simple function. It's just telling, so all functions have documentation in R that follows a very similar structure. I want you to get familiar with that. So the first part of this help for this specific function is giving us a description of what it does. So this is just a description of what it does. And then it has an usage. So sometimes here in the usage is going to show you the function, is going to show you its arguments. And if there is any argument that has a default value already being used, it's going to show you that here in the usage. So we can see that this function has an X argument, a trim argument, and an na.rm argument. And in the case X is the object you want the mean of, trim, we're going to see soon here what it does, and then and that's the default value is 0, and na remove, it's set to false by default. So this is the default behavior. And then you go to the arguments part of this, and it gives you more information about what those arguments actually do and how we can change them if you want. I'm not going to go through them very extensively, but I just wanted to show you this. And then normally it has this value section of the help, which tells you a little bit more information of what you get and how you can change things. If this was based on a paper, it gives you the reference right there. And then it gives an example at the end. So this is really useful. Sometimes you just need a quick example to see how that's been used. This is a place that I go for that. So this is, basically a very common documentation for any function. I just wanted to get familiar with it. So what we see here is, well, let me actually take one step back here and let's do the following. Let's create another object. I want to call this B2. So B2 gets, let's give it 3 numbers again. So I want to use the C function to concatenate with the same numbers as B. So 10, 15, and 5. But then I want to give it an extra value here that is an NA. Make sure that NA is uppercase. If you do lowercase, then R thinks it's an object name and we don't have an object called NA. So make sure it is uppercase NA. R is case sensitive for everything you do. So when you're naming your objects, when you're naming your columns, when you're trying to retrieve those to do something, always keep in mind that R is case sensitive. So if you write your object as B2 lowercase and then you're trying to print B uppercase 2, it's not going to work. Okay, so let's run this. So this object is created in our environment and it's available for us to use. And let's get the mean of B2. So if you ask for the mean of B2, you get back NA. And the reason for that is if you come back to the documentation of this function, you're going to see that this NA.rm, which stands for NA remove, is equal to false, meaning that it's not removing any NAs before it does the mean. And because the NA is part of the mean, it returns you NA by default. And a way that we can get around that is by changing this argument from NA remove equals false, which is the default, to NA remove equals to true. So let's try to do that. So mean B2. Let's call that argument name na.rm and say true. You can either spell out true if you want, but if you just use T or F when it's false, that works as well. So now if we remove, or if we tell the function to remove that NA first and then do the calculation, then we get back the same value as we were getting when we were just doing this for B, which is what it should have been. And I want to make a point here that this is something really simple, but it's going to happen to you, I'm sure of it, at some point, and you should be aware of how to fix it. So every time that you use a function in R that gives you a statistical summary, so it could be mean, median, mode, minimum, maximum, CV, standard deviation, all of those functions, if you have an NA in the column that you're asking that function to operate on, it's going to give you NA back. So remember, if that happens, you just need to change that NA remove to true when you do that. Okay, so I guess a couple concepts here. One is the NA issue, but also I want to talk a little bit more about the arguments themselves, right? So if we look on the documentation, well, let me take a step back. Let's try something else here. So if you notice, I explicitly called the argument name here, right? But what would happen if I just said mean of B2 in true? What would happen if I do that? It gives me an error. So what happens here is if you do not call your argument names explicitly, R is going to interpret that you're giving those arguments in the order that the function operates. So in this case here, the
Hey,
order.
Dr. Bastos,
Yes.
quick question. So when you change that, the remove of NAs to true, so that doesn't permanently do it from B2 for moving forward, it's just for that one line?
Right. It doesn't permanently, it doesn't affect the data itself. It's just on the fly, kind of removing that NA and doing the computation with what's left. But the NA
Right,
on the
thank you.
data frame, it's still going to be there.
Gotcha.
Yeah, good question. Okay. So so this didn't work because B2, so is when you do not call out the argument name of a function, it will interpret on the same order as the function was built. So in this case, it is expecting X and then a value for trim, then a value for NA.rm. because trim is actually an argument that only accepts numerical values, it threw you an error because it doesn't know how to handle a T for trim. How can we fix this issue? So one of them would be to explicitly call in that argument name, right? So we can say mean X equals B, NA remove equals true. Right, so this would fix that behavior. And even though NARM is not the second argument in the order of this function, but it knows that you're calling it because you explicitly call its name, so it knows how to handle it. And this is to an extent that if you are explicitly calling the name of the argument, it doesn't even have to be in a similar order to what the function is telling you. So we could have even said mean NARM equals true, X equals B2, and this would still work. So completely flipped order of the arguments is still work if you're explicitly calling the argument name. I want to call this to your attention. It seems like something very simple, but sometimes as you start getting more familiar with packages, you're going to start not calling your argument names because you already know how to use the function. You just give it what you know it requires. And sometimes you may get some problems, and this is one way that you can kind of troubleshoot it and think, am I giving it the right argument? Is it not interpreting in the correct order? Should I explicitly call this argument name or not? So it's just an exercise for us to think through that. All right. Any questions? Yes.
Can you add more arguments? In your documentation, it says that the fourth one,
Yeah, so this, so some functions will have this ... And I personally have not used it a lot. I think this is used more like if you're writing a function where you want to do, in this case, do the mean, but also consider other components of a function down the line, and you want that to pass along together. You can use these. At least in this case, there are some cases that it's more clear, like, okay, you have this ... and then it tells you, like, look into this function to see what options you have as part of the ... which is not the case here. But yeah, so the answer is yes, but I think I rarely use that, so I don't expect you to use that a lot either. But if it gets to that, we'll look into that as well. Yeah, thanks. Okay, so let's come down here to the next part of the script on the package. A very important concept here that's to start learning R is that as you're already done, you already installed some packages, right? And you use a function called install packages for that. And I want to make a clear distinction here that packages in R, we install them once. Maybe you install it again in, I don't know, whenever a new version of that package is released and you want to update the package, then you use again this function install.packages. But it's something you're not going to be using a lot, right? Do you have a question? Oh, sorry. So normally we use install packages function once for that package. So let's go ahead and install a package that you did not install, at least not as part of the intro script. So let's call this function install.packages. Let's give it the open and close quotation marks. I want to install the package called Tibble. If you send that to the console, it's going to install this package. I hope you don't get any issues. It's a pretty straightforward package. And I just want to tell, well, yeah, let me tell a little bit about this package. So Tibble is a package that was developed by RStudio that really helps you to work with different data sets. And we're going to see one example of this soon. But one of the main things is that Tibble and data frames objects are very similar. So Tibble has the same functionality as a data frame. However, it has some options that make it more friendly. So it prints it more nicely. And we're going to see that in a moment. And I want to, yeah, so for now, we just install this package. And then So we install packages once for that package, or maybe again when you want to update it. But every time you launch R or RStudio and you want to use a package for that session, you have to load that package. To load a package, we use a function library. So let's say library Tibble. So when I use this function library Tibble, it basically makes the functions within that package available to me in this R session. If I close this R session and I reopen the next second, I have to again use the library Tibble function if I want to use those functions from that package. So again, this distinction here is install packages you use once just to install that package. You can even comment it off. So if you just add a hashtag, a pound symbol there, you comment this off and then it's not active anymore in your script. But in the library function that loads your package every session, you need to use every session. Okay. So next, I want to create a data set with your information. So, I just want to ask for maybe 4 of you to help me out here, where we're going to get some information that we're going to be using to plot in a second. So for us to create this data set here, we could use the function data.frame as we use already. I do want to show you an alternative that is actually coming from the Tibble package. So here we come and we give it the assignment symbol, and let's call this function named Tribble. If when you type it, if Tribble doesn't pop up, it may be because you forgot to load the package Tibble. So Tribble comes from package Tibble, and you have to load the package to be able to use this function. Okay, so the way that we create a data frame using this function is a little bit different, and I think it's more intuitive actually than what data frame does. So let's give it the column name that we want. So I want the first column to be called name. And the way we do that in this function is we give the tilde symbol and we say name. So this squiggly line is called tilde. So tilde name. I know some people may not have this symbol in your keyboard. Anyone doesn't have or couldn't find that symbol in your keyboard? As a Brazilian that speaks Portuguese, we use that symbol a lot, but I think we're one of the, well, I guess in Spanish also, but not too many languages use.
Symbol. Yeah, I'm unable to find the symbol.
Okay, so let me copy this and paste into the chat. So you can copy and paste from here. We may need to try to find an option to have that symbol available to you, because there's a few functions that we're going to be using in the course that will require us to use the tilde. I guess you can also, Google it and copy and paste from there, but if you can
Okay,
find it.
thank you.
Yeah. All right. So the next column, so give it a comma. The next column I want to have is called height. And then give it a comma. And the last column I want to have is fav crop for favorite crop. I want to ask you that after this last comma and before the closing parentheses, just give it a few returns, a few enters, just so we break here the space and we can add some information. So the way that Tribble works, well, let me show you the first example and then I'll come back to that. Okay, so I wanna ask for some volunteers that I want to know your name, your height, and your favorite crop. Any volunteers here in Athens? Yes, let's go there and then I'll come back to you. Yes. Okay, so because name is going to be, a character type of object, I want to open and close parentheses or quotation marks for that. So I gave it the first value of the name column. I gave it a comma. Now your height. Say that again. 160. Okay, so let's do 160. Notice that 160 is a number, is numerical, so I'm not giving in quotation marks. Then I give it a comma, and what's your favorite crop? Rice. So I open and close quotation marks and say rice. Okay, and then after rice, I add a comma and I hit return. So I'm ready to enter the data for the next person. And before I do that, I just want to, call your attention here to the way that Tribble creates a data frame is more like the style that you would do if you're in Excel, like you're filling cells, even though we don't have cells here, but that's kind of the approach, which to us, I think to most people, it's more intuitive. On the data.frame function, the way it does is you say the column name and you give it all the columns of all the values of that column at once, and then the other column and all the values, which works, but I guess it's not as intuitive, right? As you're doing like cell by cell sort of. So that's why I wanted to expose it to this function as well. All right, thanks, Renalisa. So yeah,
Jazzy,
Jazib. Okay, so everyone, please code on your side as well.
168.
168. And your favorite crop?
Alfalfa.
Alfalfa. Perfect. Thank you, Jazib. Okay, let me add a comma there, hit return again for the next volunteer. Any other volunteers here in Athens? Yes, it's
Anis,
okay.
177.
177.
Cotton.
Copy. Perfect. All right, so adding a comma there and then hitting return for the last volunteer. Let me see. Let me pick on someone online. Someone online want to participate?
Yes.
All right, go ahead.
Usman,
Say that again.
US,
US
USMAN.
AN. Usman, like that?
Yes.
Okay.
182,
182. And then favorite crop.
maize.
Thanks. Awesome. All right. Thanks, Usman. All right. Well, thanks for our volunteers. Let's now try to run this. If you run it and you get an issue, what I would say is make sure you have your tildes in the right place. Make sure you have all of your commas after everything. Make sure you did not give a word without quotation marks. Those would be the most common issues. Let's say if I did forget to add a comma right here, which is common. A lot of times I forget my commas as well. If that's the case and I try to run it, it's gonna say, error, unexpected string. It kind of gives you some hints of where it is, even though it's not gonna tell you you're missing a comma. So you can see here that it seems like there's something going on between alfalfa and anis, right? Based on the error that's giving me. If you look here, also R tries to give you some indication of where the error is happening. So you see that there is this X, this red X on the left side of the code. If you hover over it, it says expected comma after expression. So even though it's not completely 100% clear saying you're missing a comma here, but it gives you some hints, and then you can kind of troubleshoot that way. We're missing a comma right there. Okay, well, if we print it, so if you just run the name of that object and you print it, this is what you should see. Let me take one step back here, or one moment here to ask, was everyone able to create this data frame? If you were not, please let me know. All right, I don't hear anything, so I'm gonna keep going. Before we continue with the coding, I just wanna bring here your attention to one of the differences between a data frame and a tibble. So a tibble, again, it is basically a data frame. It's just a different name that was given to this type of data frame that it just prints more nicely. So if you remember, let me print here D, so we recall the data frame that we have when we created that with the data.frame function. This is what it gives us. Now let me print intro. So you kind of compare. So see that when we print intro, it's telling us that how many rows it has, how many columns it has. It gives us the column names like the data frame did. But also one difference here is that it tells us what is the object type of those columns. So CHR stands for character, DBL stands for double, which is also, it means numeric, and then favorite crop is also character. So it gives us that information right off the bat. And also one very important difference is that if you ask to print a data.frame object in your console, and if you have a lot of rows, it's going to print all of them. So sometimes I've had data frames with, I don't know, thousands of rows that I accidentally asked to print, and it just, and it's not what you want, right? It really, we normally don't want to see 1,000 rows on your console. And Tibble has this default behavior of only printing, I don't know, the first, I don't know, 10 or 15, something like that. So even if you have a very large data frame and you forget that you should not be printing a very large data frame because it may freeze your R session, Tibble, if it is a Tibble data frame, it's not going to print all that. It kind of has a safeguard for that. But besides those differences, they act the same way. So when you're modeling, when you're plotting, when you're doing anything with that, with those data, they act the same way. Okay, so you know, we already learned about the class function. So I just want to make the point here. Let's just check the class of this object that we call intro. You're going to see that it has a few different classes now. So one of them is data.frame, which is the same as our previous data frame. But then is also TBL and TBLDF. So these are just some other different classes because this is a Tibble. So it behaves differently because of that class when you're printing it. Okay, so next thing I want to do is to use the function summary. So let's say summary intro. So the summary function is going to be very important for us. And I just want to point out what it's doing. So the summary function is going to take each one of your columns. And if it is a character column, it doesn't really give you very useful information. It's just saying that it has 4 rows. But if it is a numerical column, look at height, what it did. It already gave us a statistical summary of your minimum value, first quantile, median, mean, third quantile, and maximum. And this is really useful. So, you know, sometimes you're going to see that you're going to have, for some of the machine learning exercises, you may have, I don't know, over 100 columns. It can be really difficult to open a data. Imagine if you open this in Excel, looking at 100 columns and maybe 1,000 rows. It's tough to make sense, right? We are not good at making sense of data like that. So when you get something like this, it's really useful, especially for a first skim on your data and trying to understand, do I have any data that does not make sense? So let's say if I have a height here that was like 1,000 something centimeters. We know that's not biologically possible, right? So there is a mistake. The same way if you bring a data set and you have yield data, and then your yield is like some unreasonable, biologically impossible value as your maximum, or even as your minimum, you know, that gives you some hints that you may have some issues in your data. And this is a first look at that. This is the one function I use a lot to get a first look at that. So you'll be using this function a lot for your work as well. Okay, a couple other functions that I want to show you here. So the first one is called head. So if you say head intro, so the function head is going to give you, I think this is the top 6 or 10 rows of your data. In this case, we only have 4 rows anyway, so it's not any different from printing the whole data set. But just to show you the concept, this head function has an argument called n. If we change n to 2, that is controlling how many top rows is printing. So now it's only showing us the first 2. Again, for this specific data set, not very useful. But if you have a data set that's very long and maybe that's not a Tibble object and you just want to get an idea of the first row, so you see like, okay, what's going on here, the head function can be useful for that. And if for some reason you want to look at the last observations instead of the first ones, there's a function called tail. So if you say tail, intro, and equals 2, is going to show you the last 2 rows of this data frame. All right. So next, I want to expose you to a concept of how can we extract specific rows or columns of this data set if we're interested. I want to make a distinction here and say that the way I'm going to show you is not the way that you're going to be using most of the time on this course. The way I'm going to show you is very base R, in the sense that is something that it was done a lot and used a lot in the beginning of R. And nowadays we have packages that do this on a more intuitive and faster, I mean, I don't know if faster, but more intuitive for sure way that we're going to be using, more in this course. I do want to show you this though, because this is the history of it. And there's still some cases where you may use what I'm going to teach you right now, even though it's not going to be a lot of times. So, okay, if I want to sample just the first row of this data, let's go ahead and write the name of the data frame. So that's intro, and then open and close brackets here. So the way that it works here is on these brackets, we have this X, comma, Y. So X is the position of the row, Y is the position of the column. So if I want the first row only, what I would do is come here on X and say 1, because I just want the first row, and then I leave Y empty. And if I run this, that gives me only the first row that has data for Mona Lisa. Okay. Next, if I want the first column only, so I say intro, open and close brackets. And I'm typing here X and Y. These are not arguments. These are, it's just for us to kind of place our head in this. But so if I, based on what you just learned on how to do the first row and knowing that X is the row position, Y is the column position, how would you change this to make, so you retrieve just the first column? Okay, so I heard, let me go to you first. So what did you say, Jyoti? Okay. Perfect. Yes. So notice how now by doing that, we got only, so leaving nothing on the X position or on the row position and leaving number 1 on the column position, we just got the first column. That's exactly it. Now, what if I want multiple rows and multiple columns? In this case here, if I want rows 1 to 3, meaning 1, 2, and 3, and then also columns 1, 2, and 3. So we can say intro, open and close brackets. Because I want rows 1, 2, and 3, and that is a sequence, I can use this concept of using the colon, giving the starting point, the end point, and a colon between them, because if we just run this, it unfolds into the sequence. Let's say even if I had if I wanted numbers 1 to 10, I can say 1:10, I get a sequence that goes from 1 to 10. So this is a quick also tip if you want to make sequences. So if I want the rows 1, 2, and 3, and also the columns 1, 2, and 3, I can just do this. And if I run that, notice how now we have basically the first 3 rows. So we left to the last person, Usman, out of this data frame. And then we only have 3 columns anyway, so we're still retrieving all 3 columns. Okay, and the last part here is, what if I wanted rows 1 and 3? So I do not want row 2, I just want 1 and 3, and then also columns 1 and 3. So let's start typing intro, open and closing brackets. So if I know that some of you here may have already been doing this a lot, so you may know the answer to this. I mean, you may know from previous experience. If you're thinking through this right now and you're not quite sure the answer, but you think you have a feeling, please feel free to speak up. We're not looking for the right answer. I'm just looking for you to think about it if you have not thought about it yet.
could you make a parentheses and then 1,3 and close it and then separate it by a comma and then use columns for the columns, the same thing? Like you're separating them in their own group with the parentheses, maybe?
Is that what you're
Yes, sir,
proposing?
that was my thought. I don't know if it's right. I was just curious.
Okay, no, I like that. I think you're in the right direction. So if we run this, it's not gonna work, and it's not, the error message is not very intuitive either. But I like what you're thinking as far as we have to bundle these things, right? These numbers into, and give it to that part of it. What are we missing here? Can anyone help? C function, right? So Pramad's saying we're missing the C function. Let's try that. So if we give the C function and we run it, yep, so we got row 1 and 3 that was Renelisa and Anis, and then we got columns 1 and 3 that was name and favorite crop. Yeah, so every time we're bundling things and giving it to one component of a function, we always want to use that C function. Thanks, Austin. Appreciate the help. Thanks, Pramod. Okay, so again, I wanted to make you familiar with the syntax because you may come across this, you may see people that are using the syntax for actually doing these filtering and selections of a data frame. So I wanted to be familiar with it. We're not going to be using this from this point on, just so you know, but still a little bit of history, I guess, that I wanted to be familiar with. Okay, so let's start making some plots. I left you the code already there. If you have not yet, please go ahead and install the package ggplot2. And then make sure you run the library function as well so you can load it. So we have access to those functions. Something I forgot to mention, and just to explain why do we have to load functions every time? What is the concept behind that? So as you start developing more and more things in R, you're going to start realizing that there are so many packages out there, and you're going to be installing a lot of packages that I don't know how many packages I have installed on my computer, but I want to say maybe more than 1,000. So that's a lot of packages, really, really a lot of packages that you installed kind of like as an app in your phone. And if R were to make all those packages available to you in every R session, that would be kind of heavy, and especially because you probably don't need all of them together in the same session. So that's one way that R kind of makes things a little bit lighter is you install once, it is available on your computer, but then if you want to actually use that for that R session, you have to load it. And then you're going to realize there are maybe 10 packages that I load every single time I do something in R. And those are very common packages that people use. ggplot2 is one of them. So I guess just a little bit of history of why we have to install and then load a package using library function. And another piece of history, I guess, of background. So there are different ways, different philosophies of making plots in R. The first one that was created is what we refer to as base R. So like there is a function in R called plot. This one. This graphics package is one of the packages that is native to R. So there are some native packages in R that come with it that you don't have to load every time, but everything that you install yourself, you do have to load every time. So graphics is one of those that we do not install ourselves. It comes as native base R packages. And this plot function is from one of those packages. However, what people started realizing as time went on is that base R functions for a lot of things, including plotting, were not very intuitive. They were not very concise in the way that you think of how to make that happen. And because of that, different people started making different packages to kind of address that issue. So in the plotting landscape, there are three ways that people refer to as making plots. One would be base R. Again, we're not going to be using base R in this course. The other one that I've seen a lot of people use is called lattice, because there's a package called lattice. It's like lettuce like this, not the vegetable. And the third one is ggplot2. So ggplot2 is the one that we're going to be using here in this course. And the reason why I personally use that is because I think it's more intuitive. I think it gives you more freedom to change things yet still in an intuitive way. And ggplot is one of the packages that is developed by RStudio. As you start getting more into the data science world, especially on the R side, you're gonna hear a lot about Hadley Wickham. He's like a wizard of R, I guess, of RStudio. He's a scientist at RStudio that developed many of the important packages we're going to be using. He's kind of a hero in the R data science community. So he was the developer of ggplot too. And what RStudio at large did was to look at all of these components of a data analysis. So importing data, wrangling data or processing data, modeling, plotting, all these things that we do throughout all analysis, and looking at how it was done in base R. And in base R, they do not follow all this a similar syntax or a similar philosophy of how we express them. And they thought, let's start creating our own packages that do that in a more intuitive way and still following a very similar philosophy and syntax across all of these operations. And so ggplot is that for plotting. And again, it is part of one of the RStudio packages. And in R, you're going to hear a lot about the tidyverse. The tidyverse basically means what I just said, is this compilation of packages that most of them developed by RStudio, some of them were not, but they all kind of speak the same language. If you understand one, it's pretty simple for you to pick up another one that does a completely different thing, but still following a similar philosophy behind it. So that's what the tidyverse is, and we're going to use a lot of the tidyverse in this course. ggplot is the tidyverse package for plotting in R. Okay, so let's start thinking about a plot here. Let me first print intro below here so you can see again what that is. And I want to ask you here, if you are doing this plot, it doesn't, you don't even have to think of R coding terms, just like if you were doing this even by hand, if that's the case. Which column here would you put on the x-axis? Let's begin with that. Name, right? I agree. I think that's a good content in here. So we can put name on X, and then what would you propose to go on Y? Height. I agree, right? So height is the only numerical variable here, so I think that makes a lot of sense. Awesome. Okay, so let's do that, but in code now, and seeing how we translate that into ggplot code. So to start a ggplot, we call this function ggplot. Here it has a few arguments. Is there someone out there? Oh. We should. Yeah, so we have this classroom scheduled for the whole semester. Yeah, thanks. Thanks, Vermont. Okay, so within ggplot, when we want to make a plot with ggplot, we start off with this function called ggplot. The first argument here is the data, and that's very common, right? A lot of functions, the first argument is the data. So we say data equals intro. That's the name of the object where our data lives. I want to add a comma and hit return just to make it easier to see the code. There is another argument here called mapping. And so this mapping argument here is basically where we're going to specify how the plot is going to look like. And to do that, we don't just start typing like values. We have to give another function here that is AES. So AES stands for aesthetics. And inside of this function, we're going to set up how the aesthetics of this plot are going to look like when it comes down to what columns and how we use them in this plot. So for example, inside of AES is where you would say X equals to name, comma, I want to hit return just to break the code, the line and make it easier. Y equals to height. Okay, if you hit return a few times, I just want to make you familiar here. You should have two closing parentheses, and if you just like have your cursor visit each one of those, you can see which function each one of them is closing, because it kind of blinks. So that's a good way as well to know if you're missing a parentheses or if you have maybe an extra parentheses. Okay, so first off, let's just go ahead and run this. So if you were able to write the code without any issues, you should have seen this output on the right-hand side under the plot tab. So what's going on here is that ggplot basically did what we asked it to do. It put the name on the x-axis, it put the height on the y-axis. Notice how what ggplot does is it looks at your data, it looks at the range of values and already gives you a range of that axis that matches the range of your value. So this is not starting at 0, it's starting already at close to your minimum and close to your maximum. Okay, so if you look at this, ggplot gave us this scaffolding, this canvas of our plot, but it's not showing our data yet. And the reason for that is because we did not tell it how to show our data. So let's do that next. I want to come here, I want to add a plus after that last parentheses, and then hit return to break code. And then now we're going to tell ggplot which geometry we wanted to use to make a plot for us. So if you start typing geom underscore, and you just take a quick look here, you're going to see there's a lot of options for different plot types that we can add, different geometries we can add here. And well, let me ask you all this. What type of plot do you think we could ask ggplot to do here for us? So if you're thinking of like a scatter plot, a line plot, an area plot, a point plot, a line plot, all those different options, and even others, how do you think we can show this data?
A point of
Point or bar, right? Those are the best options as well that I think. And I do want to go with point. I mean, both point and bar would be good here, but I want to go with point because there's some specifics of a point that I want to use to show you something else. So let's go ahead and then just populate that with geom point. And then if you run this, now ggplot added a point to each one of the heights that we have for the different names. Okay, cool. Now, let me just print intro again so we can see it. And remember that we have this favorite crop column that we 11:30. Okay, so let me just think. Yeah, gotta refresh there. So we still have this favorite crop column here that we have not used in this plot yet. How do you think we could include that variable as part of this plot? Labels? We can do that. I don't want to show that right now, but that is a great option, and we will be using labels at some points. But if you think of like more on how this plot looks like, perhaps, how could you incorporate favorite crop? Color, okay, color. Yep, I agree with that. So and you're going to see this a lot. I want to share a reading with you that you're going to be able to explore. So we can change the points in this case. We can change the color. We can change the fill, which for now, let's just not talk about fill, but we can change fill as well. We can change the size of the points. We can change the transparency of the points. We can change the shape of the points. So they could be points, squares, triangles, so on. Also, all those are all aesthetics that we can change according to the values of a column, right? Which in our case, we want to change, let's say, the color of these points based on the values of the favorite crop column. So to do that, we can come back here on the aesthetics function, give it a comma, hit return, and say color equals fab crop. If you just run that, and you look at the output here, so now ggplot basically looked at your favorite crop column, looked at how many different levels you had under there, and for each one of those levels, it gave a different color, already gives you a legend, and so on. Right? Another thing that we could have done, and I just want to show you here. So if you change this in the aesthetics at the ggplot function level, if you add more geoms below it, so let's say we're going to start doing some very complicated plots at some point, and the way the ggplot works is incrementally. So you add a plus, you add another geom. So, I mean, you don't have to do what I'm doing now, but I just want to show you, I think it's maybe this. Yeah, so notice now I just add another geom column just by adding that. And then you keep adding plus and adding things to it. And if you change aesthetics, in this case, color, at the level of ggplot, that perpetuates for all of the geoms that come after. I want to delete the geom column here just because I just wanted to show you that perpetuation, I guess. So you see how the columns also have the outline of them colored according to the same as the points. But if I want to change just for this specific geom, the geoms also have an aesthetics function. So I could come here and say aesthetics inside a geom point, and I just want to delete this from the upper level and just paste that here and run it. And you would also have the same output. It's just that now, it's being controlled at the level of that specific geom. Okay, so what if I wanted to, well, sorry, my head is thinking about a lot of things. One thing I want to tell you first is, if you notice, we have 3 columns represented in this plot, right? So we have something on X, something on Y, and something coded as color. ggplot, and you're going to learn this throughout this course, allows you to add multiple columns, information from multiple columns as different components of the plot. I mean, really, I think maybe the maximum I've done was probably 6 or 7 different columns in the same plot. It's for us, if you think of if you have all numerical variables and you're just trying to make like a regression type of, or a scatter plot of that, our minds cannot really understand. After we go beyond even 3 to 4 dimensions, our brains cannot really interpret that anymore. But in ggplot, we can still bring those different data as different components of this plot. So imagine that even if we had not yet another column here, let's say if we had, I don't know, where you're from as a column, we could change the shape of the points based on that column. So it would be yet another dimension that we're bringing to the plot. Of course, it starts getting complicated, but it is possible, and that's something we do every time we're trying to change an aesthetics of the plot and map that to a column. That has to go inside of the AES function, and we can do that with multiple aspects of this plot. What if I wanted to just color all these points something else? If I just wanted to have all of them red, for example. Maybe I can come here and say red. Maybe I can try that. No, it actually did work. I was not expecting for it to work. But normally when we are changing everything to one value, in this case, all colors to one value that is red, we want to have this outside of the AES. So it would be here. And the difference, I guess, is if you have an AES, it gives you a legend, but you don't need a legend really if they all have the same value, right? Because it's not teaching you anything new. So just a reminder and as an introduction to ggplot, if you're changing something according to the values of a column, it has to go inside of AES. If you're changing something that is related to one color or one shape or one value of something, then it goes outside of AES. Okay, so I guess one more thing that I want to do here is I want to undo this color equals red because I do want the points to be colored by favorite crop. And I also want to change the shape of these points to be according to favorite crop. So all I'm going to tell you is that there is an argument inside AES that's called shape. But I don't want to tell you where to put that. I'm going to ask for some help. Maybe somebody that hasn't spoken today yet. How would you, Chris, let me ask you, where would you try to change shape according to favorite crop in this code?
On the layer of the geom point,
Okay, so somewhere here.
if you want to, you probably look at options for geom point to see what the arguments are.
Okay, I like that. Let's do that. So I think that, so if you look here at the help of geom point, I mean, it has a lot of text. So the mapping is where the AES function goes, right? So that's what we're changing. Has a data, stat position. These are not what we're looking for necessarily. So here it has some of the components that we can change inside of the statics of geom point. So X, Y, alpha is related to transparency, just so we know. Color normally is the color, the inside color. No, sorry, is normally the outside. So like the boundary of that shape is normally color, and then fill is the color of the inside part of that shape. Then we have shape. Yeah, so we do have a shape argument here that goes in the AES part of it. So where here would you put that?
So instead of AES, so a comma after big crop. I put on it like,
Okay,
then yeah, we could do shape equals 3.
awesome. I think that's gonna work. Yeah, that worked. Thanks, Chris. Yeah, so as you can see here now is not only the color, but also the shape of the points that are being coded according to different crops, right? So we have like a green triangle and a red dot and so on. So both things are being changed within here. Great, awesome. So I want to ask you to copy all this ggplot code. So make sure. Oh, and also another tip here. If you want to copy something and you want the whole row, if you come here on the numbering on the side and you just click on that number and drag that down, that copies the whole line for you. So it's one easy way to just highlight a lot of text. So paste that under customizing actually. Okay. So there are so many different ways of customizing this plot that, do you have a question?
Can we change the scale so that it includes from 0 to?
Yes, we can. I don't think we're gonna have time to do that today, but that is, because really we can change so many things about this plot that we could take a whole semester just talking about ggplot. But I like what you're thinking. I like that you're thinking of ways to change this, and I think that's going to be a great mindset as we start learning, because you're going to have a lot of options to change here as we move forward. I want to show two very quick ones to you all today before we wrap up. So one of them is, everything we're seeing in this plot is the default behavior of ggplot. So if people that use ggplot, if they don't change anything about it, is normally going to see plots with this gray background, with the white lines, with this scale of color here. It's a default of ggplot, right? how do we change this? So there are multiple ways of doing that. I want to show one that's very straightforward. So let's say if I want to change these color value, like I don't want red, green, and whatever these colors are, I want something else. So let's add a plus here, hit return, and start typing scale underscore color. And as you start typing color, notice how many options that are for you. There's a lot of them. And I want to just call your attention to one of them. So let's use, okay, I don't have the one I was thinking here. So let me think of a different one. Let's use Virides. Let's see, Virides D. So you see, so Virides is a very, very popular color scheme across data science, regardless of the language. You're going to see this name a lot. You're going to see these colors a lot because this is perhaps the first color scheme that became very popular as an option for color blindness safeness. So if you want to make a plot that you know is going to be safe for people with color blindness, Virides is one of those schemes, color schemes that is very popular. So if you just go and use Virides B, Virides, you see here there is Virides B, C, and D. That's because B is for binned data. We're not going to go into that today. C is for continuous data, and D is for discrete data. So we have our color is based on favorite crop, which is a discrete variable with a categorical variable. So let's use Virides D for that. Okay, so it did change the colors according to this color scheme that is called Virides. I want to encourage you, if you just like, not right now, but I just want to show you here, if you just delete until the color underscore, there's going to be a lot of other options. I do want to ask you to play around with them, see, if there's another one that you like, that's going to be part of the assignment. But for now, let's just keep Virides D for discrete. And then another way that we can customize this plot is by changing what in ggplot language is called a theme. So the theme of this plot is really everything else that's not related to the data. So the color of the background, the color of the lines, the font size, the font type, where things are located. The theme controls, I don't know, over 100 parameters of this plot for sure, maybe even more than that. So one quick way to change a theme is let's add another plus here, hit return. Let's call this function. So there is a function theme by itself. But there's also a lot of theme underscore. If you do theme underscore, there's a lot of options here as well. Well, maybe not as many, but we can increase this by installing other packages. But for now, maybe let's just change this to theme. Let me try theme dark, see how that looks like. Okay, so you see how, we changed some of the background colors and so on. And I do also want to encourage you to play around with the themes. So if you just leave the word dark and just leave theme underscore, hit tab, you're going to have a lot of options. You can also play with them and see if you find one that you like better. Oops, change to BW. Let me change back to dark. Okay, so yeah, I think we're going to be able to finish this today. So for now we have this plot. It's there. I mean, it's definitely not a publication ready plot, but we're still learning how to change some things and as we move along. So let's say I want to export this plot here. So there is a function in ggplot called ggsave. So let's just type that ggsave. What ggsave does is it looks at the last plot that you produced, and that's what it's going to save. So we don't even have to tell what plot it is. We just have to give it a path. So open and close quotation marks and hit tab to see where you are. So if you hit tab and it populated with your script, that's because if you come here on files, this is where it's seeing, this is where it thinks you are in your path of your computer. So if we are in this folder right here, let's just go ahead and do this ggsave right here. We can call this plot1.png. So if you run that, notice that I gave a name, but also you have to give the extension within that name. So .png is the extension. And then if you go on the right side on your files tab, you should see now a plot1.png. And if you click on it, it's going to open that on your computer. Right, so we're going to be using ggSave a lot. That's how we're going to export plots to file that then you can use in your presentations, your papers, and so on. Okay, so for now, let's just skip this RStudio projects part, because I do have an assignment that you can do this. I mean, this is very simple, straightforward, but I do, you can do this by until before next class. So what I'm asking you to do here is to play with scale color. I want to explore some available options and choose one different from the one that we use in the class. So in the class, we use Viridis D, use a different one. Also, I want you to play with themes, explore some different themes. There's a whole bunch of them. Maybe there's some that you like more. You may even start using that for your research. So explore the themes and also change that theme to one that is different from dark. I want to say this again one more time, because last time I taught this, I guess some people did not understand this. If you submit the output of this exercise and you have either the same scale color or the same theme, you're losing points. So don't do that. It's very simple, very easy. You just change your scale color to a different one, your theme to a different one. So you play around with that, choose one, whatever it is. Whenever you export, I want you to export that by adding your last name to it, like this. And then I'm going to have an issue on GitHub called assignment 1, where you're basically going to go in there and just upload this PNG file to GitHub issues, and that's going to be your submission. Very simple, easy. Could do this in 2 minutes, potentially. So you don't have to do it in class. We just have three more minutes, but I want to come here and take attendance for today. So I am back on our GitHub repo. I'm going to go under issues. I'm going to create a new issue called attendance, January 11th. Please go ahead and claim your attendance by just dropping me a note in this issue. You have to do this in class. If you forget, it's harder for me to know if you are actually here. So please do this during the class. So right now. And then you can submit. I'm going to go ahead and also open assignment 1. An assignment 1 issue where you're going to come here and just there is a link here for adding attachments. So if you add an attachment that's a figure, it's just going to populate there, and then you just submit that. All right, so that's all I had for today. Next class, we're going to start off with some reproducible tools, a quick lecture, or maybe not as quick, but a lecture on reproducible tools, and then start using some of them, and then start a data wrangling exercise. If you have never heard of this is basically like data transformation, management. I don't really know a better synonym for that. But data wrangling is something that is going to be really, really important for you for every project you do, including for this class, but also for your research. So it's a very important skill, and we're going to start learning about this next class. I think that's all I had for today. If you want to, I guess I will have 1 more minute. If you want to do the assignment before then, you're welcome to, but you have until before next class period to submit it. Let me know if you have any questions, any issues. I'll be glad to help you if you run into those. And I guess that's all for me. Thanks.
Hey, Dr. Bastos,
Yeah, let me just get Kim online first and then I'll come to you. Yes, Austin.
Just, I had an error pop. I was trying to do it real quick and it said, error in palette when I changed mine.
Okay, can you open an issue on GitHub and paste that?
I sure can.
Because then, maybe other people can also help and if not, I can jump in and help as well.
Yes, sir. I can sure do it.
Awesome, thank you. Yes,
So for assignment, do we have to email it?
no, just you're uploading to that GitHub issue called assignment 1, that's it, that's your submission. Yeah. So
I have a question.
Yeah.
Yeah, actually, I got into class 5 or 7 minutes late, so I have a question about saving the workspace, like where we gonna save our work, like if we log in again, like try
Yeah.
to use.
Let me, that's a great question. So everyone, please go ahead and on your script. If it is kind of grayed out like this, it's because you have something that you have not saved. So please go ahead and click on that save button. This save button here saves your script. It does not save your environment. So the reason why we don't save environment is first, because if you have the code and the data, you should be able to reproduce all the objects in your environment, right? Because they came from the code and the data, if you had data as part of it. Yeah, so really the only thing we want to save here is your script, what you worked on today. Your environment, you don't want to save it. Was that your question?
Yes, and I have one more question, like after saving this, where, sorry, where this file goes?
So this file here should be the one that you copied into the intro folder. Right? So in the beginning, I don't know if you were here when you were setting the,
I wasn't here, so that's why I was asking.
yeah. So I think if you follow the beginning of the recording when I uploaded, you're going to be able to catch that.
Okay, thank you.
Awesome. Thank you.
Thank you.
Thanks, Hipper. Good to see you.
Good to see you. Thank you.
All right. Let me.
This is